All right, calculus 31.3, we're talking about one-sided limits, okay? One-sided limits. We just got finished talking about limits of a function, and if I could just go back to those notes here, we had some diagrams, and here was one of your questions, right, in the assignment, and I did mention, when you asked about x approaching 4, I did say that as x approaches 4 from the left side, or from this side, the value of the function approaches positive infinity. It goes without bound. And as x approaches 4 from the right side, it approaches negative infinity. And because the function is not coming to a predictable spot, there's no limit. Because the function goes whoop, okay, a limit doesn't exist. Well, 1.3 formalizes that concept of one-sided limits. So in 1.2, where we talked about does a limit exist? Well, here in 1.3, we find out sometimes why a limit doesn't exist. But we can also split a limit up into a left-hand limit, or a left-side limit, and a right-side limit. So that's what we're going to talk about. One-sided limits, 1.3. Okay, so if you hear me say a left-hand limit, or you might hear it or see it left-side limit, okay, not sure if you see that much, but a left side limit, or approaching a certain number from the left side, we're talking about a left-hand limit. Now, there's some notation for sure, and I'll show you that right now. The limit of the function as x approaches 1, now you notice this little negative sign here as an exponent on the 1. What that means, it's different than in chemistry or physical science, where that's a negative ion. It's not a negative ion. What it means is that as x approaches 1 from the left, so when you see a little negative as an exponent there, that means a one-sided limit. And why is it important? Well, because the left-hand limit and the right-hand limit for the same number may be the same, or they may be different. Now watch, here's an example. So as x approaches 1, okay, so look at this. The limit of f of x as x approaches 1. Well, there is no definite limit here. As x approaches 1, the graph does different things. So there isn't just one number that the graph seems to center in on, right? Like, it's not like just one number, boom, at the tips of my fingers. It's like two different numbers. It's like this, two different numbers. So you would say the limit doesn't exist, but the left-hand limit does exist, and the right-hand limit does exist. So if we talk about this in terms of left-hand limits, so let me do this. The limit of f of x as x approaches 1 from the left side. And that's what I have right here. The limit of f of x as x approaches 1 from the left side. If this was f of x, this red graph right here, I can see that as x gets closer to 1 on the left side here, the graph gets closer. It responds to that by getting closer and closer to x equals, or y equals 1. Again, let me say that again. As x approaches 1 from the left side, that is numbers like 0.5, 0.75, 0.8, 0.9, 0.95, 0.99, 0.99999. What happens to the graph? Well, the graph responds by getting closer and closer and closer and closer to 1. It clearly is coming to this point, 1. So that's why the left-hand limit is 1. Now, the right-hand limit, this is super easy. Isn't this easy? So easy. The right-hand limit is symbolized by the little plus sign there. So you've got a little plus sign as an exponent on there. And this says, what is the, and I'll just erase this so don't give it away. What is the limit of this function as x approaches 1 from the right side? The right side. Well, different color. As x approaches 1 from the right side, it's getting closer to 1 like this, see? What's the graph doing? Well, the graph is going like this. It's inching towards a limit, and that is inching towards this value. Right there. It's inching towards that value, even though doesn't exist there. It doesn't exist there, but it's inching towards that value, okay? And so as x approaches 1 from the right side, the limit of this function is clearly approaching 2. So if I go back, okay, I didn't say this in the last section, but look at, as x approaches 4 from the left, the limit actually does exist. It's positive infinity. As x approaches 4 from the left side, the limit is positive infinity. As x approaches 4 from the right side, the limit of the function, where is it heading to? All the way down to negative infinity. All right. Mind-blowing? Left-hand limits. Okay. So we need to understand this, that left-hand limits would exist here. Right-hand limit exists here. But the general limit, and I say general in quotes, you may see it mentioned different ways, but the overall general limit only exists if the left-hand limit and the right-hand limit agree, or if they are the same value. Okay? Where you have a left-hand limit approaching a and a right-hand limit approaching a, then a is your limit. But if the left-hand and the right-hand limits do not agree, then you would say you do not have a limit there at that number. You would only have a one-sided limit, or a one-sided limit, but not a overall general limit. Okay? All right. Here's a little exercise, and I would encourage you to jot this down. I know this is not in your textbook. I made this up. But I would encourage you just to really quickly draw your little axis here, take a minute, and recreate as best you can. I mean, that just has to be kind of close. Recreate this random function, okay? So go ahead and do that. We're going to take a look at some left-hand limits and overall limits. We're going to spend a few minutes on this. So go ahead and copy this graph down, and then we'll go one at a time at these limits, okay? So on this random graph here, we're going to talk about some one-sided limits and some general two-sided limits, okay? So this graph is pretty random. We have a little curve here. We have a gap here at x equals 2. And we have an open-ended part at x equals 5. I have a closed dot here at x equals 5 way up here. And then this part of the graph races down towards negative infinity as it approaches 7. And this part of the graph races towards positive infinity as it approaches 7 from this side. So let's take a look over here on the left first of all. So write this down if you don't have this associated with this graph. What's the limit of f of x as x approaches 2? Okay, well, as x approaches 2 from the left and from the right, I have to check to see if the graph that is responding to this approach is approaching a single limit. And of course, the graph here is approaching this point, which that point has a value of 3. So yes, the limit of the function as x approaches 2 is 3. And that's what we've studied before. We know this. That shouldn't be an issue, okay? When x is very close to 2, y is very close to 3. So what about the left-hand limit, okay? The left-hand limit as x approaches 2 from the left. Well, that's just this half. And that means we just look at this part. And as it approaches 2, well, this graph seems to get very close to approaching 3. So the left-hand limit is also 3. The right-hand limit, so limit of f of x as x approaches 2 from the right side, and we already drew this, well, it's approaching this value, which is the value of 3. So notice the left-hand and the right-hand limits agree. That's why we have a limit, a general limit for 2, okay? So visually, because you can kind of see, and I'll just highlight this, you can kind of see that as you move along this graph, there's a very light little hole, like a skip over that hole, you see? It appears to be continuous. It appears to be completely continuous. So that means the left-hand limit and the right-hand limit are agreeing. Okay? So what about as x approaches 5? So I'm going to start with the limit of the function as x approaches 5 from the left. So write that down, and we'll take a look at the graph here. Here's x equals 5. And as the graph approaches, or as x approaches 5 here, the graph is approaching this value right here. Clearly, it's approaching y equals 1. So I would put, from the left, I would put the limit here from the left is 1. Okay? The limit of f of x as x approaches 5 from the left is 1. The limit of the function as x approaches 5 from the right side, so that is x approaching 5 from the right. Well, if we go up here and look at the graph, what's the graph doing? The graph is approaching a certain value as well, and that appears to be this value, which is y equals 4. So I hope you can see in blue here that as x approaches 5 from the right, the graph is responding by approaching y equals 4. So if I consider the left hand and the right hand limits as x approaches 5 from the left and right, they do not agree. Therefore, the overall general limit as x approaches 5 does not exist. Okay? Because, again, the graph is approaching to different places, so there is not a single limit that the function is approaching. There exists a left-hand limit and a right-hand limit, but because they're different, we do not have a general limit. Okay, and one more over here. Let's talk about this x approaching 7. Well, from the left, x approaches 7, then y responds by approaching negative infinity. And you can write negative the infinity symbol as your limit. That is appropriate. It's not a number, right? It's not a number. It just means that it's getting smaller and smaller and like a larger negative indefinitely. So we say that it approaches negative infinity. What about 7 from the right side? Well, as x approaches 7 from the right, the graph is responding by getting larger and larger and larger without bound. It is approaching positive infinity. And so if we're talking about a limit around a vertical asymptote like this, okay, where the left-hand limit approaches positive infinity and the right-hand limit approaches negative infinity, then this does not exist either. Okay? Simply because the left-hand limit and the right-hand limits do not agree. Okay, so that's just a brief introduction on left-hand and right-hand limits. I will talk about these types of graphs here in the next section. In section part 2, it's called piecewise functions.